I am Franco Ojeda, and I'll be going over the following strain rosé problem. So right here, as you can see, we have the gauges. We have gauge 1, gauge 2, and gauge 3. I've labeled them as A, B, and C. And then I got this from Appendix B. We have modulus of elasticity at 28,000 ksi, modulus of rigidity at 10,800 ksi, and these are the given values. Strain A is negative 300 times 10 to the negative 6, and it's at 75 degrees. Strain B is at 200 times 10 to the negative 6 inches per inch, and it's at 0 degrees. Strain C is at 425 times 10 to the negative 6 inches per inch, and that's at negative 75 degrees. So as you can see, this gauge is on the x-axis, so that means that it is equal to strain X. So strain B is equal to strain X, and we already have that value, so we just equal them together. And using my equation sheet, so we start off by using the strain rosé equations. As you can see, we can equal strain A to strain X cosine squared theta A plus strain Y sine squared theta A plus gamma XY cosine theta A times sine theta A. And we'll just plug in the values. Okay, so we got negative 300 times 10 to the negative 6 is equal to strain X. We have strain X, so we can just plug that right in. Then cosine squared theta, we have theta. It's 75 degrees. We just add this, strain Y. We don't have strain Y, so we just write that. Sine squared 75 plus gamma XY cosine 75 times sine 75. Okay. And then we can simplify that. Plug it into my calculator. We get cosine 75 squared times 200 to the power of times 10 to the negative 6. And we now calculate for that. So let me just write this down. 1. Okay. We find sine squared of 75. We get 0.933. Share Y plus gamma XY. We need to multiply these two. Cosine 75 times sine 75. We get 0.25. Gamma XY. excuse me, I actually confused the 2 degrees. This should actually be positive. This should be negative. Okay, yeah. So we change these, change the signs. I've previously done the calculations, and I believe the only sign that changed was when you multiply it by sign. Yeah, this should be negative. Okay. Just double check. Yep, okay. Yep. Okay, calculations are good. Okay. Now we just bring this over to this side. So negative 300 times 10 to the negative 6 minus previous answer. And we get, okay, negative 313 times 10 to the negative 4 is equal to 0.933 epsilon y plus negative 0.25 gamma xy. So this right here is our first strain rosé equation. We will be plugging that into the matrix after we find our strain rosé equation for C. So basically use the same formula except C instead of A. So, okay, 425 times 10 to negative 6 is equal to sigma x, and we know sigma x. Just put in 200 times 10 to the negative 6 cosine squared, and instead of 75, I believe, yeah, should just be 75 instead of negative 75. Plus epsilon y sine squared 75. You had gamma xy cosine 75 sine 75. So the only sign that should change is this one right here. So you get essentially same thing for this one. Okay. Let's see. 425 times 10 to the negative 6 minus 0.3397 times 10 to the negative 5. And we get 411 times 10 to the negative 6 is equal to epsilon y sine squared. Actually, let me just calculate this real quick. And we get 0.933. Okay. And then for this one, it should be the same thing, just positive this time. And then gamma xy. Okay, so now we have 2 equations, and we have 2 unknowns, which is gamma xy and shear y. So in order to calculate this, we go to matrix, and then edit, we plug in our different values. So we'll need a 2x3 since we already know what epsilon x is. So we already have that. Okay. I previously plugged it in. Okay. Yep. Okay, looks like we're good to go. We go to second matrix math right here, RREF, and then matrix again. We select our matrix and we calculate. So as you can see, it's kind of hard to see, but we found our values that we were looking for. So share y is equal to 52.63, and then we got gamma xy is equal to negative 1,450. And I believe that these are times 10 to negative 6. Okay. Let's see, next step. So now we have our gamma xy and our epsilon y. We now calculate for sigma x and sigma y using Hooke's law. So I have my Hooke's law equation right over here. So let's just calculate. Forgot to mention that we have to calculate for Poisson's ratio in order to do this problem. So let's start off by calculating for Poisson's ratio, and we do this by using the modulus of rigidity. So we can find the equation in the book. Here it is, and we have our E and our G values already, so we just plug those in. So for G we have 10,800. For E we have 28,000 KSI, and then 1 plus V. So okay, so from here all we do is find the inverse, because we want to find the Poisson's ratio, which is this right here. So we can just find the inverse. Okay, 2 times 1 plus V, 28,000. And we just bring this over here and we divide it by 2, and then we subtract 1. 8,000. I got 2.59. Divide that by 2 now, and subtract 1. 2.59 divided by 2, subtract 1, you get 0.296, which we can just round up to 0.3. And then I believe that the Hooke's law equation uses squared a lot, so we can just do that right now. Okay. So now that we have these values, we can just use Hooke's law, which is right here. Okay, so our E value is still 28,000. Okay. So now we calculate for sigma x using our Hooke's law equation. Okay, 1 minus 0.09, and then share of x plus v epsilon y. Okay. Now we just plug in the values that we previously found. Okay, 52.63, and just bring this over here. Y. Gamma xy is equal to negative 1450 times 10 to the negative 6. Okay, so now we just plug in our values. Just calculate this part real quick. 28,000 divided by 1 minus 0.09 is 0.91. Again, this is equal to 3,769. Okay. Now we use our values. I remember this being equal to our strain B, our B gauge. And it was, I can double check. I'm sure it was 200. Okay, yes. 200 times 10 to the negative 6. Plus Poisson's ratio. We use this one. 0.3 times. Okay. Strain Y. Okay. 52. 10 to the negative 6. Okay. 0.63. 3 times 52.63 times 10 to the negative 6. Actually, we can just add that later. You add 200, and then you get 215.789, which you multiply by this. Wait, actually, you first add the 10 times 10 to the negative 6, so do second answer, do negative 6, and then you multiply that by 30,769. And that gives us a sigma x of 6.64. KSI. This was KSI. Okay. Yes. Sigma y. We just use the same. Okay, this is the same. 30,769. except this time we use epsilon y. Where is it? It's over here. 52.63 times 10 to the -6. And then we add Poisson's ratio times epsilon x, which is -200 times 10 to the -6. Okay, let's calculate that. 0.3 times -200 times 10 to the -6. And then from there you just add 52.63 times 10 to the -6. And let's see. From there you just multiply by 30,769. Okay. 0.3 times -200. Okay, that is -60. Gotta double check my work real quick. Then we add this right here. 52.63. Okay. And then from there, we just multiply it. Let's see. Okay, let me just rewrite that. -6 times 769. Okay. Just double check my equation. Okay. Yep. Okay. Not sure why I put a negative here. Okay. That makes sense now. Plus 52.63. Okay, now that makes sense. Times 3769. And we come out with the final answer of 30.47 for sigma y. Let's see. Our next step is now to find our principal stresses. So we gotta find this right here. Okay. X plus sigma y over 2. Plus or minus, and sigma x minus sigma y over 2 squared plus tau xy squared. Didn't calculate tau xy, so that is equal to G value is equal to 10,800. 1,800, and then we calculated our gamma xy to negative 1450 times 10 to the negative 6. Okay. Now we get tau xy is equal to should be a simple equation. We get negative 15.66. Okay. Here we just okay. We just plug in our values. This one. Okay. Divided by 2 plus or minus. Okay. 6.64 minus 3.47. Should put KSI 47 divided by 2 plus tau xy, do it right here, squared. This is also squared. And let's see, this would be equal to 5.03 plus or minus, let's see, 15.66. That would give us a value of okay, wait. No, that's not right. 6.64 plus 3.47 divided by 2. 0.05 plus or minus 6.64 minus 3.47 divided by 2, and now we just square root that. And then we add the square root of negative 15.66. Okay. So it's 269.29 and plus or minus 16.41. Okay. Okay, so from here we just add to find sigma 1. for 6. For sigma 2, we just subtract. .36. The units on this, I believe, should be in KSI. Okay. Then now let's calculate our tau max, which should just be 16.41 KSI. Okay. Now on to my Moore circle section. Okay, so use this right here. Strain x gamma xy over 2 strain y negative gamma xy over 2 equal to, this would just be equal to 200 times 10 to negative 6 and negative 10 4 5 times 10 to negative 6 divided by 2, which is negative 25 times 10 to negative 6. This should be sigma y 52.63 times 10 to negative 6 and just regular 70.25. Okay, so now we draw our Moore circle. Okay. Okay, so 2.63 will make 725 right there. Negative 725 right here. So over 2. Excuse me, just okay. Make 200 over here. Just epsilon strain. Make it times 10 to negative 6. And then we have a point right here. Should be positive. And then we have a point right here. Negative. Connect them. Now we draw our circle. Up. Okay. That should be our max value. X over 2. Okay. Not very to scale, but this is what we need to find. In order to do that, we need to find the regular radius. We know that the diameter is 200 times 10 to negative 6. You subtract 52.63 times 10 to the negative 6. Divide that by 2 and we get 73. Wait, yes, 73.69 times 10 to the negative 6. That would be our radius. So from here to here, I believe. Now we gotta find our center of the circle. Put it flat so it's easier. Calculate for the center, and this will be, let's see, 52.63. Six, and we just add the radius. Times 10 to the negative 6. So from here, what we should get is 126.32 times 10 to the negative 6. Okay. Now we need to find this right here. Radius. This should be our strain 1 and our strain 2. Okay. And notice how this looks like a triangle. So we will be using a Pythagorean theorem. Should be A, B, and it's equal to R. So this is equal to negative 725. Squared plus 73.69 squared. We will multiply this by 10 to the negative 6. Okay, so we get an R equal to 7. 29 times 10 to the negative 6. Okay. From here, we find straight 1, which is just equal to, let's see, our center. Just right here, 126.32. So 126.32 times 10 to the negative 6 plus 729 times 10 to the negative 6. And that gives us 1 equal to 55 times 10 to the negative 6. Okay, now shear 2 will be 126.32 times 10 to the negative 6 minus 729 times 10 to the negative 6. Give us a value of 602.42 times 10 to the negative 6. Okay. Now to find gamma max, or yeah, this point right here, that is equal to the radius that we calculated earlier, and 729 times 10 to the negative 6, each multiplied by 2. And that gives us a value of 1450. Okay, now we use Hooke's law. Just shown right over here. Okay. Previous previously calculated this value. Shear x is equal to, let's see, 300 and check real quick. 3,000. Okay. 30,769. And multiply this by shear x. Yeah. So our shear x is equal to should be this, shear 1, I mean. Just write down the equation. Make it easier. Okay. 855 plus 0.3 times negative 602.42. This will also be times 10 to the negative 6. Okay. Three times 602, negative 602.42 times 10 to the negative 6. Or actually, do that at the end there. And then we add 855. So it'll be 674 times 10 to the negative 6 times that. Okay, so just multiply this. 3769. So it gives us a value of 20.75 KSI. Okay. Now to find shear y. It should be shear 1 actually. I mean normal stress 1. Normal stress 2. We just flip the epsilons that for normal stress 2, we just make this epsilon 2 and this epsilon 1. So we just do this right here plus 0.3 times 855. Okay. 3 times 855 plus negative 602.42. 46 times 1,769 times negative 6. Okay. .42 plus 0.3 times 855 Let's see, let me just double check my calculations. Then I add that. Okay, negative 602.42. Okay. E 10% to negative 6 times 30,769. Let's see. 3,855. 3,769. This should be this does not seem correct. Let me just retrace my steps. Okay, so negative 602. Okay. Okay, let me just check the equation again. 602 plus 0.3. Times 855. 0.3 times 855 minus 602 times 42. 69. 3, 4, 5, 6. Okay. Ratio, okay. 30,769. Okay. There we go. Not sure if my calculator malfunctioned, but finally got the answer I was looking for. So should be sigma 1, sigma 2, negative 10.64. Okay. This should be in KSI. I'm missing one more thing. Oh, the tau max is equal to G. Okay, G, and then gamma XY should be equal to gamma XY 10,800. Okay, previously made this calculation and it was negative 15.66 KSI. Okay. So that is my solution. Thank you.